Some volcanoes can cause apocalyptic destruction to massive areas and destroy entire cities. Others, however, can create tropical paradise islands or entire land chains. The type of volcano you are likely most familiar with is called a stratovolcano. The main other type of volcano is a shield volcano and is much flatter and broader. The primary difference between the two comes from where and how they form. Stratovolcanoes are usually the result of a subduction zone where two tectonic plates meet and smash into each other. The heat generated by the subducting plate causes lighter minerals within to rise to the surface. When this happens on a continent, it forms mountain chains with mighty volcanoes such as the Rockies with Mount St. Helens, while oceanic plates create chains of volcanic islands such as Japan with Mount Fuji. The destructive power and conical shape of stratovolcanoes mainly comes from the type of lava that erupts from them, which is often rich in strongly bonded silica and very viscous. This lava may not flow very well, but it is very good at building pressure. Once the pressure breaks, ash and debris can be thrown miles into the atmosphere and spread over an entire continent. In extreme cases throughout prehistory, this ash has been able to block out the sun for extended periods. However, while they contain enormous destructive ability, they also carry essential minerals to the surface of the planet that would otherwise be buried miles below our feet, allowing plant life to flourish and our ecosystems to thrive well after the destruction is over. Shield volcanoes are often much less extreme in their destruction. These volcanoes typically form from a divergent plate boundary where the crust is at its thinnest, or from a mantle plume or hotspot where buoyant pools of material seep up through the mantle. The lava that bubbles out of the crust in these areas, mainly basalt, is much less viscous than that formed at convergent boundaries, so it can flow much more quickly once it reaches the surface instead of either staying in one location or building in pressure until it's launched into the sky. Though there are shield volcanoes on land, including truly ginormous ones like Olympus Mons on Mars, this lack of viscosity makes hotspots and rifts ideal locations for building islands, probably the most famous of which being the Hawaiian Islands. Hawaii serves as a classic example of how a shield volcano functions. As lava trickles out, it can flow massive distances until it finally reaches the sea and cools, expanding the island's boundaries. A new ecosystem is formed after the leftover basalt breaks down into a nutrient-rich sediment. With a lack of destructive explosions and a constant supply of materials from deep within the earth, plants and animals alike can thrive in an idyllic land that keeps on growing. So, while all volcanoes may hold certain similarities, not all function the same. Stratovolcanoes are often much more destructive and can cause massive and sudden changes in the landscape that influence the surrounding ecosystems for millennia. Shield volcanoes act much more slowly and are less likely to destroy a civilization. This is not, however, to discount the power of shield volcanoes. They are still an example of one of the most potent geological phenomena on our planet and can still build enough pressure to cause a relatively large explosion. Remember, no matter the viscosity, no matter the location, and no matter the name of a particular volcano, lava still burns.